Now let's move on to another string subroutine. This one is going to be the string copy. So we're going to take a string, and the string is going to be in a certain set of memory locations, and we're going to copy it to another set of memory locations. So in the example here, we have the word hello, and then we're going to copy hello into a different string. So we're going to copy it into string underscore copy. So we're going to push the string, we're going to push the string copy, and then we're going to jump to the string copy subroutine. So we jump into the subroutine, and the subroutine copies the same values into the new string copy location. And then it ends. So that's the calling function. So let's see the actual subroutine. So the subroutine, we do our housekeeping. We then pop off the return address, and we pop off string copy and string, and then we work through this little loop. So we load the value for string into R0, and then we do the comparison because we want to see whether it's actually an empty string. So we check for the null operator, or we want to check and see whether the next value that comes through is the null operator. So if it isn't the null operator, then it comes down and it stores the value in the memory address pointed to by the contents of register R2, which is the string copy. So we just copy the H into the first address of string copy, and then we increment R1 and R2 so that we move on to the next value here, which is the E, and we move on to the next value of string copy. And then we go back up to the beginning of the loop, and we continue round this loop until eventually we get the null string coming through. Once we get the null string coming through, we jump down to here, and of course we want to make a copy of the null string as well. So we do this at this little section here. And then we do the rest of our housekeeping. We restore the original values for our registers, and then we jump to the return address. So we jump back up to the calling function here, and that's the end of it. So let's go ahead and we will see this working in the actual CPU. I have loaded the subroutine into the ROM and the calling function into the RAM. Now before we run it, we're going to go through the same process that we went through in the previous video. So we know we're going to copy the hello, and we have to copy the delimiter. So we need to actually see that the delimiter is actually copied. So I know that the delimiter is going to sit in this position here. So we could put in 1111. Now the reason why I know it's going to sit in there is simply because we're going to have an HELLO, then the delimiter, and then the copy is going to be HELLO, and then the delimiter. So we'll put 1111 in there. Whenever we run through it, this should change to 0000. So let's run through that now. And you'll be able to see the actual ASCII values heading into register R1. So that's HELLO, and that's us finished. So let's stop this, and then we will head in and we'll check this out. So we're going to have the original string 1, which is HELLO, and then the delimiter, and then the copied string, which is going to be HELLO, and you can see that the delimiter now has actually been added because the 1111 has changed to 0000. So it does work, and that's another string function that we have available to us. Now we are going to go through some more string functions, and we may well add in some more mathematics functions and some more graphics functions, but we're not going to do it right now because we have gone over maybe, I don't know, 25 or 30 different subroutines, and it's all going to seem very much the same if we just continue in that vein. So what we want to do is kind of break things up a little bit. And what we really want to be able to do is represent fractional parts of numbers. So for example, if we want to do a sine function or a cosine function, then the sine cosine range between -1 and +1, and they're fractional values. And we don't have access to any fractional values, so there's a whole swathe of mathematics that we can't do. Everything that we worked on so far is integer based, although we have come quite far with integers. So what we're going to do next is look at fixed point arithmetic, and we are going to implement a fixed point arithmetic within our CPU. Now, this is going to be a kind of cameo of a fixed point system. We're not going to do the full fixed point system because I have actually designed a floating point unit, and we will integrate this floating point unit within the CPU on the next course. So that's the course after this one, and that's the one where we will actually get access to a full range of real numbers that we require in order to generate lots of interesting mathematical functions. But the fixed point stuff that we're going to do next is a nice little lead-in, and it will let us do quite a bit more with our CPU. So thank you for listening. I'll get you on the next video. Goodbye.